Group 15, and today we are going to explain our Excel template using this user manual video. So before that, as you can see here has a table that we are going to use to generate a velocity time graph and an acceleration time graph for an object that moves in a 2D plane in the end of this video. There are some measurement unit of the object in this video, in this table, which is time, Sx the position of object in x direction, Sy the position of object in y direction, the resultant position of the object, the resultant position of direction of the object, Vx the velocity of object in x direction, Vy the velocity of object in y direction, the resultant of velocity of the object, and the resultant of velocity of the direction of the object. So in order for us to observe the movement of object in 2D plane randomly, we are going to draft the value of time, xx and xy randomly in this plane. So here's are the data of our group that we designed for the object. After we constructed this value, we can calculate the resultant position of the object using Pythagoras theorem, which is square root xs power square plus xy square. So how are we going to calculate the resultant of position of the object in this Excel? We are going to insert a equal sign, open bracket, xs power square plus sy power square, which is b8 power square plus c8 power square, close bracket, power 0.5. So by inserting this formula, we can calculate the resultant of position of object when time is 1 second. By dragging down the right corner of the column to the end, we can calculate the following resultant position for the object for the following time. Next, how are we going to calculate the direction of the position of the object? We can use the formula inverse tangent multiply with sy over sx. So by inserting an equal sign, decrease, open bracket, a tan, which is inverse tangent, open bracket, c8, which is sy over b8, close bracket, then close again, we can calculate the direction of the position of the object for when time is 1 second. So again, by dragging down the column, we can calculate the s direction for the object. Next, we are going to calculate the velocity of object in x and y plane. As we know, velocity is equal to total distance over total time. So the Vx, we are going to use the dsx over dt, and Vy, we are going to use dsy over dt. So for Vx, we can calculate by using inserting a negative sign, open bracket, by minus b8 over ay minus a8, close bracket. We can calculate the Vx when time is equal to 2 using this formula. So same as the Vy, we are going to use the sy over, like for example, c9 minus c8 over a9 minus a8 for Vy, then drag it down, we can calculate the Vy value. So after calculating Vx and Vy, we can calculate the resultant velocity of the object, which we are going to use Pythagoras again, square root Vx square plus Vy square, and drag it down for the following resultant velocity at the respective time. For the v direction, we are going to use the same formula as s direction, which is tangent inverse Vy over Vx.
To explain about the acceleration in x-axis, acceleration in y-axis, resultant acceleration, the direction of the acceleration and also the graph. So for the first one, which is the acceleration in x-axis, the formula we'll be using will be the change in the velocity in x direction over the changes in time. So we can see from the J9 here, we can see the formula will be equal to F9 minus F8 over A9 over A8. So for F9 will be the velocity in x direction, and Fx will be the initial velocity for x direction. So we calculate this by actually 0.5 minus 1.5 over the changes in time, which is 2 minus 1, and we've got the acceleration in x direction of -1. So we can actually straight away drag this in this method and got the value by using the same formula. And for the initial value, we didn't actually calculate or using the formula because it needs to depends on the previous velocity in x direction, so I straight away insert the value of 1.5. So the approach also same as the acceleration in y direction by using the formula of changes in the velocity in y direction over the changes in time, like G9 minus G8 over A9 minus A8. Same, we can straight away find all the value by dragging this. So now we proceed to find the resultant acceleration by using the formula of square root ax squared plus ay squared. So like this, j8 power of 2, k8 power of 2, and square root the whole thing. So 1.5 square plus 2 square root, and we've got 2.5. So the following formula we can use same method and drag all the way down to find the all value. So now we proceed to the direction of acceleration, which is theta, and we will calculate this by using the formula of shift tangent, the change in the velocity in y-axis over the changes in velocity in x-axis. So we will insert the formula degrees tangent k8 over j8. So we can straight away drag like this. Now I would like to explain regarding to velocity time graph, acceleration time graph. So for both of these two graphs is the resultant velocity over the changes in time. So when we see this, okay, the value we'll be using is the changes in the v resultant in t and the changes in the time. While acceleration, we can see from the value will be according to the changes in the resultant acceleration and the changes in time. So for the next two graphs, velocity time graph in direction and acceleration time graph in direction. So both of the graph is actually display the theta against time, but in velocity and acceleration manner. So we can see from the data here will be the v direction, which means the theta in velocity direction and changes in time. So for acceleration, also the changes in the a acceleration direction and changes in time.
Both of these excel from our group, which is Excel A, the left side of the screen, and Excel B, the right side of the screen. So from Excel A, we can see that it is a much simpler table than Excel B, as Excel A does not consist the direction of the object, no matter in position, velocity, or acceleration, and Excel A does not consist the velocity in x or y direction and acceleration in x or y direction. Therefore, our group have chosen Excel B for our final dynamic assignments to submit, as Excel B consists a much complete diagram and table to show an object that moves in a 2D plane. That's all from our group. Thank you.